Hello everybody, we're going to code today the simplest possible timer in pure C, using the Linux kernel as a helping hand. Because whenever you deal with time, that's something quite low level that the processor is taking care of, or the operating system. And we have to somehow listen and attach to the kernel and ask it to notify us about elapsed times. So that's going to be very interesting because I have never done it before. And I would say, instead of just talking so much, let's just create a new directory and call it timer. Now, what I want to do in this project is I want to create a file, timer.c, and the timer is going to be super simple. I don't want it to be ultra precise. It does not need to follow the best coding standards or the best possible library that we can use. It should be the simplest possible timer, just so we do some interactions with the kernel for the first time and we just get started on the learning path in interacting with the kernel. It's just the first time, so that's what I want to learn. So I found, let's create a new window here. I found that what I did is I looked up the man page for time, and that is not very useful because that is just that's just a utility that tracks some other program's time. So if you call time, for example, and then echo, or time echo hello, then that's an already existing utility that does something. So that's not what we want. We want to interact with the system's time. We don't want to use some already existing bash utility. So the man page for time is wrong, but I learned I don't know when, a couple of weeks ago, that we can use the command apropos to search through the man pages for everything related to a topic. I think it's just grabbing through man pages. And if we do apropos time, then you can see here that we get many results, and some of them, they look interesting. There's, for example, get date, change file system, file timestamps, clock set time, seed time underscore r date. So there's a lot of stuff related to time, and somewhere here there must be something that we can use, right? But I need to narrow down the search a bit. So instead of looking for time, what we want to do is we want to code a timer. So something that notifies us when a certain time has elapsed. For example, I want to read a book, and I want to spend, let's say, 25 minutes reading that book, and then I want to see a countdown timer and then be notified when the time is over. So instead of looking for time, let's look for timer and see what the system already offers. And as you can see, the results are much shorter. And we have a couple of options here. For example, there's POSIX timers, process PID timers. Let's look up that one, proc PID timers. And this seems to be a file that is located under process PID timers, and that's a list of the POSIX timers for this process. So each process that is running in the Linux kernel has an associated timers file that tracks something. But again, that is a file in the Linux file system. According to the POSIX standard, that's not exactly what we need. I want to find out how to properly implement time in C. So let's see what else there is. For example, there is timer ID, process timers, Timer create. Wait, and one important point. You see all these results here, and they have behind them, there's these parentheses with a number. For example, 2 or 3, POSIX, 2, 3 type, etc. So what are those? If we look up in the man pages, you can see that this is the man page of the man page utility. And there are different sections of man pages, and here's an explanation what these numbers are. For example, parenthesis 1 would be executable programs or shell commands. Parenthesis 2 are system calls, functions provided by the kernel. And if we exit this, then you see a couple of 2s here already. So technically, we could also do apropos timer, grep, and then parenthesis 2 and see the results. Maybe we have to put it in quotes. And those are system calls that could be used. Well, what else is there in the man pages? There are library calls that are functions within program libraries, C libraries, system. System calls are 2, of course, but those are all the libraries that you have installed probably, or for which you have installed man pages. Special files and all of that stuff. So there's a lot of documentation for everything possible, but I think the thing that we're interested in is system calls, man page, category or section 2. And there's now a limited set of stuff related to timers that we might be able to use. So let's have a look what there is for us. Is there anything usable for us? For example, there is timer create a POSIX per process timer. That one sounds quite promising, doesn't it? And there's also timer FD create, timers that notify via file descriptors. Also interesting. Get timer, get iTimer, set iTimer. So there seems to be, let's say, 3 different types of timers here. iTimers, then timers that are POSIX per process timers, and then there's the timer FD, which are timers that notify via file descriptors. That's interesting. So I would say let's try to look at, well, let's just have a look at the set iTimer one, and let's just see what this one is about. Set iTimer. Set iTimer. Get or set a value of an interval timer. So that seems to be a call in the standard C library, yeah, because it's of course man page section 2. And there are 2 functions, get iTimer and set iTimer, both of which provide access to the interval timers. System calls that provide access to interval timers, that is, timers that initially expire at some point in the future and optionally at regular intervals after that. Interval timers are actually exactly what we need, because a simple timer starts at some point and then expires at some point in the future, and then it's over. That's it. That's a simple timer. But an interval timer is a timer which starts at some point in time and then in regular intervals expires and notifies the parent process over and over. And that is actually what's more corresponding to this live clock thing that we want to implement, at least if we want to update our clock or our remaining time every second, because then we would need a notification every second. So this one sounds quite promising to me. So these are timers that initially expire at some point in the future and optionally at regular intervals after that. When a timer expires, a signal is generated for the calling process and the timer is reset to the specified interval if the interval is non-zero. Okay, there's a signal generated. That sounds like kernel level signals. Let's see. 3 types of timers specified via the which argument are provided, each of which counts against a different clock and generates a different signal on timer expiration. So we can choose one of 3 different timers with this. There's the iTimer real. This timer counts down in real time. Okay, what else would we want? False time? Just joking. At each expiration, a SIG alarm signal is generated. Then there's the iTimer virtual. This timer counts down against the user mode CPU time consumed by the process. Okay, so there's one timer that uses the real system clock, and then there's another timer that uses the CPU process time. I don't actually know what the relevant difference for me writing a program would be in that case, because in both cases the elapsed seconds should have the same length, shouldn't they? Probably there is definitely some difference. I'm just not aware of it right now. And one difference is that at the expiration, we get a SIG VT alarm signal. SIG VT alarm. Yeah, we could also look up what that one is. SIG alarm is quite straightforward. It's just a signal about an alarm. And then there's SIG VT. Virtual alarm, probably. It's an alarm about something virtual. Alrighty. And then there's iTimer prof. This timer counts down against the total CPU time consumed by the process. There's user mode CPU time. That is, I think, the CPU time that is actually consumed, that the CPU is running. And then there's also the total CPU time. Yeah, okay, that includes CPU time consumed by all threads in the process. So if a process is multi-threaded, then you have multiple processes or multiple threads consuming time, so that all adds up. Interesting. I have no idea what they could be used for, but yeah, I just want to get my simple clock running. All right, a process has only one of 3 types of timers. Timer values are defined by following structures, and then there's some syntax here, some instructions how to create those. All right, this one already sounds very promising, and it looks like this is already the thing that we could use. So maybe let's also check out the other ones quickly, but I'm very inclined to use the set iTimer one. The POSIX one, let's see. Timer create. Create a POSIX per process timer. This sounds like exactly the same thing actually for me. So maybe one is POSIX one that is compatible across multiple systems and operating systems, and the other one might be specific to me. I don't know. Yeah, this is just a variant. And there's also some program source down here. And it looks like this one needs a lot of code. There's a lot of low-level detail, as you can see here. So this timer, here's the main method, and the timer is created here. No, there's a handler for the timer signal. Okay, that one we need anyways. Then there's a block timer signal temporarily. Because before the timer's created, we don't want to react on the timer signal. I don't know. And then the timer started. There's some frequency calculations, frequency in nanoseconds. Yeah, I don't want to deal with all of that stuff. Maybe it's useful. I don't know. But I think the iTimer looked simpler on the first glance. Obviously, I have no idea. And let's have a look at the third variant, the timer FD, create. and see what this one does. Timer fd create timers that notify via file descriptors. That's actually very interesting. So it has three methods: timer fd create, then set time, and then get time. And these are also system calls that create and operate on a timer that delivers timer expiration notifications via a file descriptor. So in comparison to the first one that we looked at, the get iTimer and set iTimer, those were timers that react to kernel level signals. And here the description says they provide an alternative to the use of set iTimer or timer create. Yeah, and the set iTimer is the one with the signals that we looked at, the simple one, and then timer create is the POSIX one with a lot of code required. But actually, I don't know if this set iTimer also requires a lot of code. We will see. And then with the advantage that the file descriptor may be monitored by select, poll, and epoll. Okay. The use of these three system calls is analogous to the use of timer create, timer set time, and timer get time. There's no analog of timer get overrun, blah, 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 blah. Timer fd create creates a new timer object and returns a file descriptor that returns to that timer. That refers to that timer. So we get a timer as a file. How does that work? Is it just a file with a seconds or milliseconds or nanoseconds value written into it? But then how do notifications work via that file descriptor? Or maybe that file descriptor is only written into once the timer expires, and then we can watch the file, and when something happens in the file, we know the timer has expired. So again, we have different sorts of times that we can choose here, or different sorts of clocks that we can use here. Is there some sample code down there? Yes, there is. All right, interesting. We're not going to do that one. Let's have a look at the iTimer again. And let's scroll down and see if there's any sample code down here. There's no sample code about this one. Why? Okay, I think we're going to do this one. This one looks very promising to me because it's just so simple. We have a set timer function. The int which, what does it do? It's okay. I think we have to start coding something. So we need to include system time. I think the difference between this function here, the get iTimer and set iTimer functions, and the other ones is that this one is specific to Linux. It's system time.h, and the other ones are system timer fd. That one's also specific to Linux, I think. And then the timer create is signal.h and time.h. So this one seems closer to the kernel. That one, not closer to the kernel. All of them are close to the kernel, but this one is just POSIX stuff for compatibility across operating systems. Yeah, all right. Okay, so we need to include. That was a lot of talking, by the way, before writing the first line of code. I know many of you, or many people in the comments, maybe not you if you're watching this right now, don't have any patience looking at all of this documentation before actually writing some code. But I find this exploration of the different available timers, the different available aspects in the operating system, digging through the man pages and trying to understand stuff, there's actually a very interesting part as opposed to just churning away some code. So this is actually what's really fun to me, trying to figure out which knowledge I need to implement something. That's a huge part of actually coding something and making something work. Because you start with nothing, and then you have to make a reasonable choice. But to make a reasonable choice, you have to gather facts first. And instead of just presenting you the facts already prepared, and just writing the first line of code at the start of the video, I want to take you with me onto the journey of gathering the facts themselves, so that you can see that you can see how it can be done. And also that you might be even able to correct me in the comments in case I'm too short-sighted and overlooking something. And some of you even commented that I was reading the man pages too slowly, too fast, and I was glancing over important details. So that's why I tried to spend more attention to the details today. Because often the man pages, they present solutions to the problems you have, if you pay attention, of course, and you cannot just skim over them and then try to hack everything into a working system. Usually, if something is written in the man page, for example, let's say this sentence right here, then it's not there for no reason. So pay attention to what's written there. All right, but I think now we are ready to do something. So we have included system. No, we haven't even included system time. So let's include systime.h. And let's print f starting timer. And I would say we need also arguments, int argument count, and then the arg v. I think it's a constant character pointer, arg v. Yeah, it's an array of strings, and we want to provide one argument, and that one argument is a number in seconds. Yeah, let's say it's a number in seconds. So we're starting the timer of d seconds. And that, yeah. Okay, now we need a variable. Let's say it's an integer, seconds. And that integer comes from the first argument, argv1. And now obviously we cannot just take argv1 and put it in an integer, because argv1 is, or any argv entry is, a string. So we need to do a conversion, and I also have no idea how to convert this. I have done it in the past, I think A to I. Yeah, okay, that was a good guess from my vague memory. A to I. We pass in a constant character pointer and get as a result an integer. All right? A to I. But why is it even called A to I? What does A stand for? Convert a string to an integer? A to I? No, seriously, what does the A stand for? If you know it, please put it in the comments. This is quite confusing. Why is it called A to I instead of string to I? What about A to F? Convert a string to a double? A. Maybe because... Maybe alphanumeric to integer? I don't know. Okay. Okay, and let's see if this code that we already wrote here, if it compiles. So let's also go into the project directory timer here. and compile this using GCC timer.c, and the output is going to be timer. I hope I don't conflict with an existing binary. No, I don't. That's good. And I messed my compiler syntax up. I have to specify output timer and input is timer.c. Now I also want to specify warnings and even extra warnings and my debug flags in case I do need them. And there's no such file or directory. Why didn't I save timer.c? Yes, I did. Okay, now it seems to work. So implicit declaration of function a to I, that means I have to include standard lib. And I think if we properly read the warning, then it's probably already suggesting to us this solution. In function main, warning implicit declaration of function a to I. No, it's not suggesting a solution, I think. But in the man page, we can see that it's coming from standardlib.h. So I think now it should be working. Now, we still have a warning, but it's just about an unused parameter, which is not a bad thing right now. Or we can even, we can make use of it. If the argument count is not 2, then return -1. Or even exit -1 with an error code. Wrong usage. Or actually I should even print usage instructions. So let's printf and write usage, and the usage is the name of the binary and then seconds. And the name of the executing program, the binary, is argv0. There should always be an argv0. And then we exit, and not with error code -1 because we just print usage. I think we can exit with a reasonable error code here, not judging the user too much, because sometimes the user just invokes the executable and then without parameters just to see how it's supposed to work. So let's not throw a negative error code at them. Now it's compiling without warnings, and let's see timer, and we get a usage output in which I forgot the new line, as in almost every episode. So let's try again. And now it worked. So this is the usage. Timer is supposed to be called with seconds. And now the next step would be to specify a number of seconds, for example, 5. And then it's starting the timer of 5 seconds, which means it has parsed the input string properly. By the way, what does happen if we enter a string here? Okay, then it parses that as 0 seconds. Okay, that's fine for me. All right, and now comes the interesting part. Now we can use setTimer and getTimer, getITimer and setITimer to do some system call level interactions. So let's find out exactly what those functions do. The function getITimer places the current value of the timer specified by which in the buffer pointed to by current value. I don't need that. I want to set a timer. So setITimer, the function setITimer arms or disarms the timer specified by which. What is which? Which is the first argument. It's an integer. And that is the kind of timer that we specify. We're probably going to use an iTimer real. So while reading this, let's already write here set iTimer. And then the timer is going to be an iTimer real. iTimer real. Let's see if that one works. Okay. Setting the timer to the value specified by new value. Setting the timer to the value specified by new value. Okay, what is new value? New value is an iTimer value. It's a structure. And we probably have to create that structure ourselves. Constant struct iTimer value, new value, old value. Wait. We're not replacing anything. I just want, maybe we even need, do we need the get iTimer? I'm now confused. The set iTimer seems to be, wait, no. We need to read more documentation. Otherwise I will just do stupid stuff and people will freak out in the comments. Okay, we can set a timer to the value specified by new value. Okay, and the old value can be null. And then the buffer it points to is used to return the previous value of the timer. Okay, and this way we create a timer, and if it's a success, then a 0 is returned, on error -1 is returned. The standards are silent on the meaning of the call set iTimer which null old value. Many systems treat this as equivalent to get iTimer which old value. Blah, 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 blah. Okay. Notes. This might be interesting. Timers will never expire before the requested time, but may expire some short time afterward, which depends on the system timer resolution and the system load C time. If the timer expires while the process is active, the signal will be delivered immediately when generated. If the timer expires while the process is active, the signal will be delivered immediately when generated. Aha! Okay. Okay. So let's have a look at how to initialize the timer. I just still don't exactly get the difference between get iTimer and set iTimer. The set iTimer seems to override an existing value with a new one. And the get iTimer might. Maybe we can even use the get iTimer. The value IT value, interval value substructure is populated with the amount of time remaining until the next expiration of the specified timer. If this value changes, or this value changes as the timer counts down and will be reset to interval when the timer expires. If both fields of IT value are 0, then this timer is currently disarmed. Maybe we can use get iTimer. Okay, then let's try to use the get iTimer. Get iTimer. If it doesn't work, I mean, we can revert to the other one. So we need to create a iTimer value. Let's see what that is. iTimer value structure. And it's this structure right here. It's a structure that contains an interval for a periodic timer, which is what we want, and a time until the next expiration. So does only one of them need to be filled because I want to have a periodic timer and not a single shot timer. So in case of, or is the single shot time, for example, if I say 5 seconds here and then 1 second for the interval, does it wait 5 seconds and then continue with the interval afterwards? The IT value substructure is populated with the amount of time remaining until the next expiration of the specified timer. That's this structure here. This value changes as the timer counts down and will be reset to IT interval when the timer expires. If both fields of IT value are 0, then this timer is currently disarmed inactive. So wait, how do we exactly specify this? We have an interval and we have a single value. Interval for the periodic timer and a time until the next expiration. In any case, we need to specify a time value, which is a time t in seconds and subseconds, microseconds. So let's do that. Struct time value. It has just 2 fields and we can just probably do it very simply. Constant structure time value is equal to 0, 0. If both are 0, of course, but the first one is going to be 1 because here we want to wait for 1 second. Our timer is 1 second. Now the iTimer value derived from that, or maybe we need 2 time values. We need an... Well, I really don't know if one of them can be just null. Actually, I want to have an interval. And probably it's mentioned somewhere here in the documentation, but I just can't see it. What if I search for null? No, it's not mentioned anywhere. The IT value substructure is populated with the amount of time remaining until the next expiration of the specified timer. This value changes as the timer counts down. Ah, I see. So this seems to be a live value. I'm not even sure if we need to fill it ourselves. And will be reset to IT interval when the timer expires. Okay, so we can probably specify the interval here. And the IT value will constantly just hold the value of it. It will constantly hold a time value that contains the number, this exact time and, well, in seconds and microseconds, how much time is remaining for the current interval. That's interesting if that is the case. So I will just do this. Time value is 1, 0 and interval is 1, 0. I assume that the interval is going to be used. And then for our iTimer value, the interval is this, internal interval, and the time value is this. But I think, oh, this should be a valid structure that we defined here. And then we can specify get iTimer val, and that might be it. Let's see, the return value is then 0 if it's a success. Int, let's call it code, and then let's printf that code at the end of our execution code. Okay, Let's go ahead and try to compile it and just see what happens. Doesn't work like this. Why doesn't it work? Expected identifier or parenthesis before equals token. Constant structure time value. What's the issue there? Struct time value. Do I need to give it... Wait, did I properly define the structure? Probably not. Probably I did not. I have to give my structure proper names, of course. So I define two time value structures here, time val, and they have a name. This is the interval, and this is the remaining time. Remaining. Okay. I am really not sure how to define the structure here. Because I think I have to declare that I use this kind of structure, struct iTimer value, right? Then do I have to maybe also cast it? Struct time value. Oh, I was missing semicolons at the end of... Oh god. But I reduced the number of errors. That's already a good sign. So what's the issue here? Incompatible type for argument 2, the timer. Yeah, maybe I need to cast it to a struct iTimer value. I can just do explicitly the same thing here. I don't know how really necessary casting the structs is, but it can't harm. Let's see. Struct iTimer value. Incompatible type for argument 2 of get iTimer. Let's see what argument 2 of get iTimer is by definition. iTimer value. And it must be a pointer. That's the issue. So let's give this a pointer. And now let's try to compile again. Okay, parsing. Yeah, I think those cannot be constants because, of course, they are changing values. Let's see in the official documentation. We pass a structure, current value, and it's an iTimer value. And of course, none of those contained values are constant because they are probably modified during runtime. So let's remove the constants here and see what happens now. And there's just one more warning left, which is a very good sign for me. Too many arguments for format print fd. Yeah, of course, I missed the format specifier. And now we should be good to go. And it did compile successfully. So let's run the timer without an argument. That works. And with an argument, starting timer of 5 seconds. And the return code is 0, which means that the timer has successfully been initialized. So that means that the code is working. Now, what's the next step? We have now created a timer, but wait, we have created a timer, but now what? Now what? What do these timers now even do? I thought they send a signal? Signal? Okay, yeah, they do. So via the which, okay, 3 types of timers are specified via the which argument, blah, blah, blah. each of which counts against a different clock and generates a different signal on timer expiration. And we specified a timer that creates a SIG alarm signal. And we have to watch for that signal. Okay, so let's go down to the recommendations, and here it's already recommended to us SIG action and signal. Let's check signal out, and there's a warning. The behavior of signal varies across Unix versions and has also varied historically across different versions of Linux. Avoid its use, use SIG action instead. All right, let's not question that. The Linux gods have spoken to us. And now, here, using SIG action, what can we do? Examine and change a signal action. SIG action, what does it do? The SIG action system call is used to change the action taken by a process on receipt of a specific signal. So we set a timer, we expect a SIG alarm to be sent, and using SIG action we expect to change the action taken by a process on receipt of a specific signal. What can we do here? The call is SIG action. We specify a signal number, and that signal number is just, I think, the constant. The constant value referred to by SIG alarm. SIG alarm. No, not found. But I'm fairly certain that that's the signal number. Wait, can I even search signum? No. But what if I check signal, signum? Yeah, this one also uses signal number. Somehow this one looks simpler to me. It just specifies signal, signal number, and signal handler. What does the other one require you to do? You specify the signal number, SIG action, and old action. The old action can be null. This one is a nullable. Okay, for whatever reason. Why do we have to specify the old action? Probably that's just a structure that the kernel will write into what the old action was. And the SIG action is a pointer to an SA handler. That's probably just a function that is going to be executed. Or it is this SIG action, SA SIG action. I think we have to read some manuals here. Signum specifies the signal and can be any valid signal except SIG kill and SIG stop. That's fine. If act is non-null, what is act? Act is the action. If the action is non-null, the new action for signal, signum, is installed from action. The new action for signal, signum, is installed from action. If old action is non-null, the previous action is saved in old action. Okay, that means we can do the following. We can, in our code, specify that we want to create an action, create or override SIG alarm action. And we use that using SIG action. What's the library here? Signal.h. So let's go up here, include signal.h. SIG action, and then SIG action takes as input SIG alarm. By the way, which other ones are there? SIG error, sig ignore. A couple ones. Sig alarm. And then we need to, as a next step, specify the new action that is going to be act. And it's going to be a pointer, I think. Is it going to be, is it a pointer? Or is the pointer just referring to this nullable thing? Let's just write act here and see if we get a warning later. And the action is a constant structure sig action, constant struct sig action act, and is equal to, and now we have to define the structure. We can probably just do this, act dot as a handler specifies the action to be associated with signum and can be one of the following. Default for default action, sig ignore to ignore the signal. Okay. So here we can specify, do we want to continue using the default action? Do we want to ignore the signal in our process, or we want to override it using a pointer to a signal handling function? This function receives the signal number as its only argument. And we want a pointer to the signal handling function, of course. So this is an integer pointer, isn't it? As a handler is this, and specifies a pointer to the signal handling function. Okay, let's try to do it. The signal handling function is, let's say it's a simple printout. Received signal and, or let's call it signal handler. Does it receive an input? Yes, it does receive an input as it was described here. The function receives the signal number as its only argument. No, I understand the syntax here. So this is a pointer to a function, and it has one input argument, which is an integer. Int I or int sig number, and let's create. Oops. Hey, where's my function? Can't even read it. Oh, damn it. So again, signal handler int signum and it prints f received signal with number, and we print that to the console, signum. And that should be a valid first signal handler. And in the action we set that our signal as a handler is equal to signal handler. And this should be a valid function pointer, I think. Okay. What about the other ones? Are they even necessary? There's also the sig action field as a mask, as a flags, as a restorer. If as a sig info is specified in as a flags, then as a sig action instead of as a handler specifies the signal handling function. It just receives more arguments. Okay. I don't think we need any of those. So we don't need a special other function with 3 arguments. We don't need a mask. We don't need flags. Do we need a restorer to restore the old behavior? Where's that described? No, I will just assume that I don't need it. So we have created a SIG action with the signal handler, and that then we set the signal action to be that handler. All right, let's see. Probably I assume that this code will just run through to the end and exit, and because we exit before that 1 second interval is over, this printf statement will never ever be printed out because we have to keep the process alive somehow. So let's compile. Oh, it doesn't even compile. Assignment of member as a handler in read-only object. So signal handler in read-only object. Why is it read-only? Yeah, okay. I'm just removing the constant again. So probably I have to give the constant value the constant structure a value directly. All right, so that error is gone. Now, next error. Error SIG alarm undeclared first use in this function. Did you mean SIG? I mean this one. I just have to fix up my SIG alarm. SIG alarm. Okay. Let's recompile, and this seems to work. Now, incompatible type for argument 2 of SIG action. And it expects the pointer. Yeah, that's the one that is the error that I already assumed will happen. And now it compiles without errors, without warnings. Awesome. And let's execute the timer with 5 seconds, and it exits successfully, but nothing happens, so we have to keep the process alive. Now, I think, I don't know if this is a stupid idea. Do I have to do a while one loop here just to keep it alive? Can I even terminate the process then? Yeah, probably. But if I do an infinite loop here to keep the process alive, isn't this taking up all the CPU power then? Because this is just running infinitely fast as possible. We will try it. No warning. Okay. And let's try the timer. 5 seconds and... Ah, no, nothing's happening. Damn it. Okay, I can still interrupt the program, luckily. So something is wrong. What is wrong? The timer... What if I specify just 1 second here? No, it seems like the signal is not being sent. So let's go back to man get I timer and see. A SIG alarm signal is generated if we use the iTimer real. Which one do we use? We use the iTimer real here. So that seems to be okay. So we can trust that this works, I think. Then timer values are defined by the following structures. We have the we have iTimer value, interval timer maybe. And the interval is 1, and the interval value is the time until the next expiration. And this is a time value, seconds and microseconds. Let's evaluate our code. We say that the interval is 1 second and 0 microseconds, and the remaining time is 1 second and 0 microseconds. And then we say that the structure, iTimer value, consists of the interval and the remaining time. That should be fine. That looks fine to me. If both fields of IT interval are 0, then this is a single shot timer. Okay, what if we set it to 0 then? And also the remaining. Compile. But we don't get the signal interrupt thing. I mean the alarm signal. So something is still wrong. Then I think the timer is fine because also the code that is returned here is 0. Get iTimer. The function getItimer places the current value of the timer specified by which in the buffer pointed to by current value. I think no, maybe that this just returns some current timer that is. Wait, no. The function getItimer places the value of the timer specified by which in the buffer pointed to by current value. So we're basically asking the operating system which timer is currently running and please fill the current value. Maybe we have to say set iTimer. Probably that makes more sense. That makes way more sense actually to me. We have to set the timer. Set iTimer. Set iTimer. We set a new timer and the old one is null. We don't need an old timer. Let's see what happens now if we compile this and execute. And we received a signal with wow, this it works. That's awesome. Oh my god. Okay, so we just had to set the timer instead of get it, which makes total sense. So we are receiving the signals now. Oh my god, that's perfect. So now we have a working timer. This means now we have a working timer. The timing system is working. How awesome is that? Just 1 minute ago, I thought I'm too stupid to do it. All right, so the timing system is working and we did it completely without the internet, just looking up the man pages. And this is what makes me proud. We just figured it out by carefully reading the documentation. That's so valuable, honestly. Okay, so we are specifying a time that we want to count down, seconds. So now we have to count down from those seconds, obviously. Seconds, and the signal handler, however, only receives the signal number as input. So probably we have to act on some global variable in seconds, and that is initially 0, and we set seconds, the global seconds, to the input argument. Let's see if that works, just to track. Wait, what's that? Alarm clock? Why is alarm clock printed? I did not write alarm clock anywhere. What the hell? Why did it just print alarm clock? Did it even print alarm clock? Why don't I see the alarm clock string anymore? Am I stupid? Did I go crazy? Did I just accidentally paste something? Did I just... Where did the string come from? I just saw a string on the console that said alarm clock, but that was definitely not from my source code. Okay, let's try to compile and set a timer of 3 seconds. Now, okay, there's the alarm clock again. What does it mean? So this time it seems to run through, and here it seems to be interrupted, and then there's an alarm clock printed to the console. Huh? What's that? Maybe is this some interfering process? Alarm clock? This looks like there's some handler for the alarm that is injected somewhere or intercepting this. Override the SIG alarm action. Maybe we override the signal alarm. No, I don't have an explanation right now for this. Should we maybe override the signal alarm after setting the timer? What? What's that? Wait. It's totally confusing to me. So what's going on? We are starting the timer of such and such seconds. We're defining the interval and we're setting the timer. I think since we are now firing a signal alarm event, maybe some other process is also watching for that event, printing alarm clock to the console, and then terminating the process. But I don't get how it interferes with our process in that case. In any case, let's not distract ourselves too much from that weird other process that is just printing alarm clock to the console. I have no idea where that's coming from. If anyone has an idea, please put it in the comments. That's ridiculous. It must have to do with the signal handler. Let me just set the other actions explicitly. Maybe in SIG action, here we have different fields available. And I set the handler, but maybe there's still some SIG action here that we have to set explicitly to null, otherwise this action will stay active. And that's the default action or something. So let me just set it to null. SIG action is null. Then SIG set mask is also null. SIG set mask is 0. It's 0 because this looks like a number to me. Then integer SA flags is also 0. Act as a underscore flags is 0. Wait, no, this is not called SIG-set mask. This is just the data type here. It's called SA underscore mask. SA underscore mask. And the SIG action field is called SIG action. That's fine. Then SA restorer is called SA restorer. SA underscore restorer is null. Okay, I think maybe now our program is a bit more robust. Has no member called SIG action. It's SA underscore SIG action. SA underscore SIG action. Okay, let's compile. Incompatible types when assigning to type SIG set from type int. The SIG set SA mask. What kind of values can it have? SA mask specifies a mask of signals which should be blocked, added to the signal mask of the thread in which the signal handler is blah 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 invoked during execution of the signal handler. In addition, the signal which triggered the handler will be blocked unless SA no defer is used. Why can I not just set 0? As a flag specifies a set of flags which modify the behavior of the signal. Okay, and as a mask specifies a mask of signals which should be blocked. Well, I don't need any signals to be blocked, so why can I just not set it to 0? SIG set underscore t. Oh. There it is. SIG set underscore t. This is a type that represents a set of signals according to POSIX that this shall be an integer or structured type. But no further explanation here. Okay, anyways, then we can just probably set it to null. If it doesn't accept 0, it will accept null. No, incompatible type when assigning. What if I don't specify a mask? That seems to work. Okay. Let's see. So this is, there's still the alarm clock. But now it's always coming up. The alarm clock is always coming up. Why? As a handler is our signal handler. As a SIG action is null. So maybe we accidentally somehow always trigger this signal. But I'm inclined to just look it up online. So let's look up SIG alarm default action. SIG alarm clock. Oh, this seems to be a phenomenon. Alarm to display message every second. No. SIG alarm prints alarm clock. Signal handlers are not supposed to contain business logic or make library calls such as printf. A signal handler cannot, and in general, call standard library functions. Why? All the signal handler should do is set a flag to be acted upon by non-interrupt code. Wait, so I can't use printf? Okay. Let's see if we change our code a bit to not use printf, if it then works better. So we need a flag that is an integer. Let's say that it is called second, or yeah. Let's call it elapsed, and it's false. And here in the signal handler, we set elapsed to true. Now in our while true loop, we do the following. We check while elapsed, while not elapsed, wait, and then down here we printf timer elapsed. New line. So this should print our, well, this should, I think this should wait for 1 second here and then print timer elapsed. Let's see. But it's, of course I have to compile again. Unused parameter signum. Of course I don't need that one. So timer 2. Alarm clock. Why is it printing alarm clock all the time? This is stupid. This is really stupid. So something is obviously wrong, but I don't get what. What if I... If I don't set the SIG action explicitly to null, what does it do? It prints timer elapsed. So this seems to be working with my timer then. And all I did is just, I removed this line of code here. This is confusing. Is this documented anywhere? SASIG action is a function. What does it do? If SASIG info is specified in SA flags, then SASIG action instead of SA handler specifies the signal handling function for signum. This function receives 3 arguments as described below. Integer, signal info, and some pointer. So this is then the handler function. But this should only be used in case the SA flags are set to something. Okay, but now it seems to be consistently using my timer. Timer elapsed. Timer elapsed. Timer elapsed. Yeah, so now it seems to be working. So the issue is if we set this to null explicitly, then somehow some different magic action will be executed and is interfering with my own stuff. I don't understand why. But okay, so let me just remove this line. It seems to work now. And please, everybody in the comments, please just write what's going wrong here. And if I print f whenever we receive a whenever we receive a signal, I know this should not be done, but maybe let's just print something to the console and see what happens now. That seems to work. That seems to work. There's no alarm interfering with us. No, it seems to work now. So the best practice is, of course, to set the elapsed to 0. Then we can set it to 1 here. Then while we're not elapsed, we loop. But if no, while true, so always we loop here. If elapsed is 0, then of course no. If elapsed is equal to 0, then nothing has happened. But if it's equal to 1, then the timer has elapsed, and we can print the remaining time. And what if we do? We can probably print the remaining time here we'll get the remaining time from our timer that is running, because it will keep the remaining time always. So let's do that. Let's print remaining. Then print the remaining time, new line, and the remaining time will be timer dot. That's our iTimer interval. And we get the time until the next expiration here. IT value. Time value, IT value. Dot TV seconds. Let's see if this works. Just have to replace this with a number probably. Oh god, no. Doesn't work. If elapsed is 1, we have to print something and then set it to 0 again, of course. Let's compile and test it. So we have 1 second remaining and it's not counting down. Remaining 1. Maybe I'm misunderstanding this timer thing. But also instead of doing this, we can just do use our countdown seconds here. Countdown, let's call it countdown in seconds. Our own countdown in seconds is the argument here. Oops. And then if the timer has elapsed, then we count down. And then we say remaining seconds is countdown seconds. Maybe we can even count down here. Let's see what happens now. Ah, and I haven't refactored everything properly. Let's search for seconds. Ah, there. Countdowns underscore seconds. 210 and now -1, etc. Of course, if we have reached 0, then we can do if countdown seconds is equal to 0. If countdown seconds is equal to 0, then we can break the loop. So that's equivalent to while not countdown seconds. Once that reaches 0, then we will break the loop. So let's compile this. And this warning is a bit annoying here. Unused parameter. But of course, we're not going to use the parameter here. So can I just remove it? Will the function still work? Seems to. All right, and let's call the timer. Let's say we want to wait 5 seconds. Timer elapsed. Seems to be that the signal handler is broken if we don't. No, something else is wrong. While not countdown seconds. Or, while countdown seconds, because once it's false, then of course the loop will exit. And let's get rid of the unused variable again, signum. Here. Okay, and see if it works now. It's compiling without any complaints. Now, starting timer of 5 seconds. 4, 3, 2, 1. Timer elapsed. That's awesome. And of course, I want to also get rid of this printf, which always prints this 0 here, which is annoying. So let's try. Unused variable. Of course, we don't need the code here anymore. Or we can use the code. We just have to check if not code. That means the timer is not successful. Then that means printf timer could not be set up, and then we exit the application with an error code. exit -1. Okay. And now, timer could not be set up. Of course, if code, we have to do if code, because if it's 0, then it's successful. Always getting this mixed up. Okay, timer 5, 4, 3, 2, 1. Timer elapsed. And now, of course, we could do one more improvement to make this look much better. Instead of counting down like this, we could do we could count down in place without appending new lines here. Because realistically, I want to do a timer of, let's say, 10 minutes. So that's 600 seconds. And I don't want to have 600 lines of printouts here. So let's do printf and delete the last line. Let me look that up online. Printf, delete last line. Or printf, move cursor to beginning of line. F flush standard out. No, this is too much. I think this probably flushes the entire screen. I know I did that at some point in some older episode where I coded a bouncing ball animation in the terminal using just ASCII characters. And for that, we had to update characters in place and reprint the entire animation on the console in place instead of adding new lines. And this way we could create the illusion that the terminal acted like a video screen. And I want to do the same thing here. I just completely forgot how that was done. I know there were certain control characters which could be used. Set console cursor position. Update same line, but not in bash. Printf, update line. Let's see. You should add \r to your printf as others have said. Also make sure you flush standard out as standard out stream is buffered and will only display what's in the buffer after it reaches a new line. So we have to printf \r, print something, and then flush the buffer. Okay, we can probably just use that approach for our printf \r places the cursor at the beginning of the line. I don't know if the new line will break it, so let's remove it. Let's also add S for seconds. And then F flush standard out. Let's see. Let's compile this. Timer 600 seconds. That doesn't work because I didn't compile, obviously. Let's try again. And we have yes, it works. Awesome. It works, but this way we will never see the end. So let's see if we get a successful success message. Let's do a 3-second timer. Remaining 2 seconds, 1 second, and timer elapsed. And of course, we have to add a new line here. Does it work if we add a new line after the seconds here? Maybe not. Somehow it doesn't work. But we can print timer elapsed with a new line here. Let's just do timer elapsed, new line, remaining print out is there. Is there anything else? That might be it. Let's compile. Timer 3 seconds, starting timer of 3 seconds, remaining to 3, 2, 1, 0, timer elapsed. Alrighty, guys. I think that's it. That's it, guys. So what we now do for a final demonstration is I will create a new pane such that the code and the execution is all visible on the same screen. Just like, what's the best part of the code? What's the most interesting part of the code? Maybe all this timing thing stuff here. And then I will move this execution down here. And let's start a 60-second timer. Or no, let's start a 10-second timer and watch it count down to 0. 5, 4, 3, 2, 1, 0. And the timer has elapsed. And that's how you do timers in pure C from scratch. It took a while. It was a long journey. We read through tons of documentation, but I think we learned so much. So if you appreciate this content, then consider supporting me, becoming a Patreon. Also, if you like the way the terminal looks, consider getting my terminal environment setup pack on Gumroad. You can find a link in the description below. And one more thing, if you want to use a VPN, you can also use the offer in my description down below. This protects your online privacy. It's awesome. I use it all the time. Anyways, but I'm completely happy if you just leave a like and subscribe, and yeah, see you next time. This was incredible. This was an incredible bunch of fun. Bye-bye.